Monday and Tuesday. Okay, where do I want to start here? Start with the kidney. Okay. So, this outer portion is called the capsule. Under that we have the cortex. And then this is the pyramids, they're called. They're sort of pyramid shape. Between the pyramids is a sort of extension of the cortex called the renal columns. Now the urine's being made here in the cortex and the medulla. The medulla has the pyramids in it. But it's not really fully made into, it's just called a filtrate for a long time. And then finally, by the time it reaches here though, it's fully made. This is called the renal papilla, the tip. And that's going to collect the urine at the ends of these renal papillae into what we call the minor calyces. But the minor calyces are going to merge to form the major calyces. The major calyces are going to merge to form the renal pelvis. And then it's going to go into the ureter, which will then go to the bladder. Not shown here. Now this shows you the first step in making urine. Blood is coming in through an arteriole. And then there's a little capillary bed. And it's leaving through an arteriole. So these are both arterioles. But this is bigger than this one. So what's that going to do to the pressure here?
Increase.
It's going to be high pressure. And it's going to push a lot of things out of the capillary bed to make a filtrate. Okay. Now, there's 3 layers here. You can't tell. I don't know if I can do this. Okay. There's 3 layers here. So the first layer is going to get out some of the big stuff, like red blood cells, stuff like that. Then you have another one getting rid of the medium-sized proteins, so the basement membrane. So the capillary wall will get rid of the big stuff, like the red blood cells. The basement membrane will get rid of things like the medium-sized, large proteins, and then we have parts what are called fenestrations, we'll see later, that get rid of the small, sort of medium-sized proteins. But what gets in here then is like a plasma that's going to be low in proteins. We still have glucose, we still have amino acids. After that, we're going to go to what's called the proximal convoluted tubule. A lot of absorption there, reabsorption of stuff. Glucose is reabsorbed here, so you don't normally have glucose in your urine. Amino acids reabsorbed. We don't want to lose those nutrients, okay? And a lot of water and some sodium other stuff. Then we go to this nephron loop or loop of Henle. A lot of water comes out here. Sodium chloride is pumped out of this part. That makes this area very concentrated in salt, so that helps pull that water out. When we get to the distal convoluted tubule, there's a lot of secretion going on. We get rid of things like hydrogen ions and toxins and things like that. And we have variable control in the distal convoluted tubule and this collecting duct over how much water is reabsorbed. If the antidiuretic hormone is present, we reabsorb a lot of water. If you've been drinking too much water, then we don't reabsorb a lot of the water. We let a lot of it go through. Also, aldosterone works here, and it can cause sodium to be reabsorbed into the capillaries that are surrounding this area. And where sodium's being reabsorbed, water follows it. Okay. And notice some of these are up here, cortical nephrons. Or cortical nephron is what the whole thing is called. Some have really long loops of Henle, and these are very important for controlling how much water leaves. So whether you want to concentrate or not so concentrated urine. So these are called cortical nephrons versus juxtamedullary nephrons. And I think that's more than you probably should have right now.